Continuous integration and delivery with GitLab. In this section, we'll learn the basics on how to use continuous integration and delivery with GitLab. We'll start by automatically building images. Next, we'll learn how to automatically test images after they are built. Finally, we'll learn how to automatically deploy an image to a Kubernetes cluster. Building Docker images automatically. In this video, we'll learn how to use GitLab to automatically build Docker images. We'll discuss how continuous integration can benefit Docker applications. Next, we'll learn a little bit about GitLab. Then we'll learn how to enable the Docker registry for a project. Finally, we'll learn how to configure continuous integration on a project. At its most basic level, a Docker application is really no different from any software project. It is simply a Docker file with the resources needed for the image, usually stored in some form of version control. It is software. Treating Docker applications like code means that an administrator or team of administrators can benefit from all of the advances in software development methodologies. One of those is the automated building and testing of a project. Anytime a change is made to an application, the image can be automatically rebuilt and tested to ensure that the image will work as intended when it's deployed. I often joke that my job as a systems administrator is to get other people or things to do my work for me. The reality is that the more I can empower other people in my organization, the more effective we can all be. Using a proper CI workflow means that whenever the developers are ready to deploy, the CI tools can safely deploy the application without waiting for an administrator to get around to it. The end result is faster, more consistent, and more reliable deployments. GitLab is a wonderful tool for CI and deployment of Docker images and services. It combines Git with issue tracking, a Docker registry, and continuous integration to provide a unified experience. GitLab CI is available for free as part of the offering at GitLab.com. You can also pay for an enterprise license for additional features. GitLab is available as a hosted solution, but it can also be installed locally. Enabling the Docker registry for a project is very easy. Click on Settings for your project. Then expand the Permissions pane. Scroll down and make sure the container registry is enabled. When you're done, click Save Changes. You don't have to use the registry in GitLab to use GitLab CI to build and push your Docker images. The process we'll see here can be used with any registry. Let's start with a simple project. I've made it available at gitlab.com/perlstalker/ci-demo. We'll clone the build branch. As you can see, the Docker file is very simple. It adds a simple web page to the official Nginx image. GitLab CI is controlled with the .gitlab-ci.yml file. It is a YAML file that lets us define each stage of the CI process and what happens in that stage. The first two entries configure the build process to use the Docker in Docker build process. This is required if you are using runners at gitlab.com to build your image. The stages key is used to define the build stages. They are applied in order. Every build step in a stage must complete successfully before GitLab moves on to the next stage. If there are no build steps in a stage, the stage is skipped. The variables key lets you define variables that will be used in the build stages. In this example, I've set the docker_ci_image variable to be the image name. The build variable ci_build_ref_name will be replaced with the branch or tag name. When trying this on your own, replace the registry and image path with your own registry. The key before_script lets you specify a number of commands to run before anything else happens. We'll use this to log into the registry. GitLab uses a build token for authentication so that you don't have to embed your user credentials in the script to log into the registry in GitLab. Now that all of the setup is out of the way, we can get to the build stage. Each step must have a unique name. We'll call this step build-image. The stage key defines which build stage the step will be executed in. Multiple steps can be defined for each stage, and they will be executed in parallel. If you need to define an order, put the steps in different build stages. The tags key is used to specify tags for your build. These can be used to select different runners. To use the Docker runner on gitlab.com, you must specify the Docker tag. The script key defines the build script. This is what tells GitLab what actually needs to happen to build your image. Each entry is a shell command. In this example, the first command builds the image. The -- pull flag is used to ensure that the latest version of the base image is used. The next step pushes the image back into the registry. This is why we had to log in above. Let's make a change to the repo and push an update. Let's see what happened at GitLab. We can go to our project and go to CI/CD and then select Pipelines. Here you can see a list of all of the pipelines that have been run because of your CI configuration. Click on the pipeline ID to see the status of the build pipeline. From there, we can click on any stage to see how the process went. Here you can see all of the output of the build process. Now let's go to the Registry tab. Click on the arrow to see all of the available images. We configured our CI process to use the Git reference to tag the image. Since this was the build branch, the image gets the build tag. You can see that it was built just a few minutes ago. If we were to tag the commit and push that into the repository, GitLab would build a new image tagged with the Git tag. We can now run our new image. In this video, we learned how to use GitLab to automatically build Docker images. We discussed how continuous integration can benefit Docker applications. Next, we learned a little bit about GitLab. Then we learned how to enable the Docker registry for a project. Finally, we learned how to configure continuous integration on a project.